Hello, my name is Jennifer Pinkelman, and I will be doing this Math 111 Intermediate Algebra Test 1 review. Let's go ahead and get started, and let's go through these problems. These problems should be different than the ones that are on your practice exam and your real exam for your teachers. But these are ones that I made up with myself separately so that they might be extra practice. Might be ones that are similar to ones your teacher had on your review. Maybe some of them are completely different ones. Either way, good extra practice for you to attempt while studying for your test. The first question says, determine whether the following statement is true or false, and false, rewrite it in a form that is true. So what you have to know is that with these symbols, these greater than or less than symbols, what they mean is it depends on where the numbers are standing in this arrangement here to figure out if they're true. Well, if it's in this way, this is saying that 9.7 is less than 5.5. You might have heard that it eats the bigger number. Well, this is trying to say that 5.5 is a bigger number, which we know is not true. So in this case, I need to just flip my symbol to be this way. Now that makes it true. Okay? So this was false, and then this is me rewriting it right here so that I can go ahead and get the right answer. Now the next one says find the real numbers that satisfy the equation below. If no solution exists, write no solution. So this is absolute value, and if you remember about absolute value, you know that it represents distance on the number line. Well, distance is always positive, even though numbers on a number line can be negative, but distance is always represented as a positive number. So that's why you always have something like x in the brackets, these absolute value brackets, is equal to a positive number 5/8. Well, what are your choices? Your choices are x is equal to a positive 5/8 for your answer and a negative 5/8. And the reason why they have the negative 5/8 there, or they say that in absolute value you always get two answers, because you're accommodating the negative number line value that might be possible that will make this distance here positive. Okay, so that's the answer for this one. The last one on this page here says plot the set given below on the number line. So I'm just going to take these numbers and just put little dots on the number line where they need to go. Okay. So the first one is -3. There goes my dot. Negative half, right in between 0 and -1. Positive half, which is 0.5, which is right in between 0 and 1, and 1.5, which is right there. You can go through and label these for your professors, like this, so that they see this, so they know you know which ones that you're talking about. Okay, let's go ahead and move on to the next slide. Okay, it says know the commutative, associative, distributive, inverse, and identity properties. Let's talk about all of these. So, there are, these properties for addition and multiplication. Okay, you really don't have them for division and subtraction. So with all these, you're going to have multiple ones. So let's talk about the first one, the commutative property. I'm just going to abbreviate it this one. And they have it for plus and multiplication. Commutative property, or the word commute, means to move. In this case, you actually move the numbers of the variables around. So I could have like 7 plus a equals a plus 7. Notice the order of a and 7 switch. And then for multiplication, it's the exact same thing, where you could have 3 times 4 is equal to 4 times 3. They actually moved. That's the commutative property. A lot of times people get the commutative and the associative property confused. And the associative property, the difference is, here I'm going to write numbers move, using that little symbol for numbers. Here, parentheses moves. That's the biggest difference. So I could have like 2 plus 3 plus x, there's the parentheses, is equal to 2 plus 3 plus x, and then see my parentheses has moved, my numbers have literally stayed in the exact same spot. Do the same thing with multiplication. It could be something like a times 7 times 10 equals a times 7 times 10, and I have my parentheses here, and then there. So that's the associative property. The distributive property looks kind of similar to this, but there's not parentheses in the second part. Distributive property talks about distributing some kind of number with multiplication or variable multiplication inside parentheses. So you could have like 2x plus 3. Well, I'm actually going to work this out by putting that in and getting 2x plus 6, multiplying that out. That's using the distributive property. Notice here, it's gone. Okay? So you should be able to recognize that. Let's talk about the inverse property. So there is the additive inverse. Actually, I can just write inverse, and then I'll do the plus and the multiply. So there is the inverse. We got the plus and the multiply. Okay? The additive inverse is going to be what you get the opposite of. Inverse means opposite. So if I were to have like 2 plus negative 2, that would give me 0. So the additive inverse equals 0, okay? Which you'll see whenever we do our identities, just, they're kind of related. The multiplicative inverse is if I had something like 5 times 1/5, I get 1. This right here is the reciprocal, so sometimes they talk about this as the reciprocal property. So I'm just giving you another name for it. So you take a number like, you know, for instance, I could say 7 times 1/7 is equal to 1. Okay, so it's the same thing except, you know, just different numbers. This is the multiplicative inverse that I just did previously. That was the additive inverse. This 1 is also important because we'll see in the identity property, 1 is part of the identity for multiplication, just like 0 is part of the identity for addition. They're kind of similar to each other. So the identities, and then we have the additive. The additive identity is what number can you add to anything and still get the same number. So if I had 10 plus blank equals 10, what number is that? Well, that number is 0. That is the additive identity, okay? If I'm asking about the multiplicative identity, what number can I do times itself, or times something, is equal to the number? Well, that number is going to be the number 1. So see how these are kind of related to each other in some way? That, you know, you have your inverse and your identities, and then these two kind of go hand in hand with these problems. That's where they come from. Now, I'm going to go ahead and do the next one. I'm going to up the video like that to take a break on this. So, let's go ahead and check it out. Okay. It says here, whoops, hang on a minute. I think I missed a question. I did on this page, right there. Oh my god, I missed number 4. Let's go back and take a look at it. A pilot flew a plane from an altitude of 11,700 feet to an altitude of 11,100 feet. What was the change in altitude? So I'm just going to subtract here. Okay? And, you know, I get 0, 0, 6. That's it. Now, here's where this can get kind of tricky. It's, you know, a decrease because the plane went down. Notice how this first number is bigger, the second number is smaller. Decrease by 600 feet, or sometimes your teacher might want minus 600 feet. I know that this can be a little tricky as to which one do you write. Your best bet is to ask your teacher which one do they want on the test, okay? Because otherwise, you know, you might be a little lost by this. I don't want you to get the wrong answer if you put negative whenever they don't understand that that's what you're trying to say, that it went down, it decreased by 600. Not that your answer is technically a negative number in that way, okay? Alright, sorry about that. Let's go back and find this quotient here. Okay, so we're going to find this quotient by doing some long division. We know our rules of division and multiplication, a negative and a positive times a negative gives me a negative. Same thing if I did division. Alright, so I'm going to go ahead and just knowing that, just do long division. So 3 goes into 51 how many times? Well, 3 goes into 5 once, goes in 3 times, minus, get a 2, bring down my 1. 3 goes into 21 7 times. And my answer is a negative 17. Just right here, take that negative sign. Now these next two problems are asking about which categories apply to the number. So let's talk about this. The number 13. Well, as your teacher might have explained to you, you start with the natural numbers. Those are the numbers like in kindergarten or preschool and, you know, first grade. When you're first starting out and you count, you always start at what number? 1. 1, 2, 3, 4, 5. You don't start at 0. You don't learn 0 until sometime in first grade, maybe kindergarten later on. I'm not 100%. So 13 is definitely a natural number. You can count to 13. Whole numbers are all these plus the number 0. They just throw those in. I could do 0, 1, 2, 3, 4, 5, and so on to get to 13. Next, you get to middle school and you learn about integers. Integers are all these, so you get the N and the W, plus the negatives. So we're adding on to this as we keep going, okay? We're not taking away. You might be sitting there going, well, 13 is not negative. How is it an integer? Negatives and positives are integers. So this is also an integer, and it can be multiple ones. Don't think that it's wrong. And then it's saying a rational number. That's what you learn a little bit later. A rational number is a number that can be written as a fraction or decimal, and it's a specific type of decimal, and I'll talk about that in a minute. But I can write this as 13 over 1, so that makes it a rational number. Now let's take a little segue to talk about rational numbers. Rational numbers, like I just said, are fractions, so, it could be something like, 12 over 1, or it could be something like 2/3, okay? Also, they are decimals, but specific type of decimals. They are repeating. So, repeating, I could have 0.67, 67, 67, and so on. They can also be terminating, which meaning that they stop. So something like 0.825 stops. That's terminating decimal. Any of these are okay. They're rational numbers. An irrational number is decimals that are not like that. And we'll take a look at that right now. So let's scroll down. The next one says, check all the categories which apply to this number. Well, this number is pi. Pi isn't a rational number. Numbers like pi, if you were to type that in a calculator, you get, your 3.14, blah, blah, blah. But what ends up happening is that you get a non-repeating, non-terminating. You might have, seen in your classrooms in high school or middle school, pi stretched out to 100 places. It never repeats and it never stops. So non-repeating, non-terminating is the fancy word for it, okay? But what that just means is it doesn't repeat and it doesn't stop. So you're going to have something that has no pattern to it. Like the 676767 has a pattern. 0.333333333 has a pattern. So you get something like 0.158732119. There's no pattern here. So examples of these besides square roots besides pi are something like square root of 2, square root of 11, not square root of 9, which is 3, but weird stuff. If you punch those in the calculator, you're going to get some funky answers. There's going to be some decimals that look like that at the bottom. I'm going to stop here and continue on with the next set of questions.